Hey, this is number 2 from Miscellaneous FRQs from 2019 AP Review. This is a problem that deals with function and derivative properties. So we have functions f, g, and h are twice differentiable. So again, that just means it's a smooth curve, that the second derivative value is not going to be 0. It's going to be at least degree 2 or higher. G of 2 equals h of 2 equals 4. The line y equals 4 plus 2/3 x minus 2 is a tangent to both the graph of x equals 2 and the graph of h at x equals 2. So first thing is asking for is find h prime of 2. Okay. So we have the line that is tangent to both the graph of g and graph of h. So if that's a hint right there, that if the two graphs, or if the graph of h is tangent to this line, then that means this must also share the same slope. This line is going to share the same slope of the graph at h at 2. So if we just figure out what the slope of this line is, then we know the slope of the graph of h at 2 as well. So since our graph of h is tangent to the line at x equals 2, they must share the same slope. So our slope, this is already pretty much in point slope form. The coefficient in front of the x is 2/3, so that's our slope. H prime of 2 must also be equal to 2/3. Let a be the function given by 3x cubed h of x. Write an expression for a prime of x. Find a prime of 2. So we need to think of these as two separate expressions being multiplied together. So 3x cubed we can think of as our f function, h as being our g function. We can go through product rule. So f prime g plus f g prime. 3x cubed becomes 9x squared. The original g function, the original g function, so h of x. F is 3x cubed, and g prime is h prime of x. Replace every x with 2, and then we clean up. So 9 times 4 is 36. H of 2 is going to be the same ordered pair as this point, or it's just going to be h of 2 equals 4. H prime of 2 we already found is 2/3. 3 times 8, 16. We can clean this up all the way to show a prime of 2 equals 160. Okay. Part C, the function h satisfies h of x equals to x squared minus 4 over 1 minus f of x quantity cubed. It is known that limit as h of h of 2 as h of x as h approaches 2 can be evaluated using Hopital's rule. So using limit as x approaches 2 of h prime, find f of 2 and f prime. Show the work that leads to your answer. Alright, so let's try to evaluate the limit first. So we're just going to plug 2 in for all the x's, see what we get. We get 2 squared minus 4, which is 0. F of 2 we already know is going to be f of 2 is equal to, okay, that's what we're looking for, right? F of 2 is what we're looking for. So 1 minus f of 2 cubed. We already know this is going to, it says that it's going to go through Hopital's rule, so we know this result must be equal to 0. So now we're going to jump to our next step, Hopital's rule, which is finding the derivative of the numerator and denominator. So x squared becomes 2x, 4 goes to 0. And then 1 goes to 0, and f of x cubed, we have to go through chain rule. So bring down the 3, keep the bracket, subtract 1 from the exponent, 3 becomes 2, and then inside function's derivative becomes f prime. So we go through chain rule here, and then we reevaluate. So we plug 2 in for x, 2 in for all the x's, we get f of 2, 4 over negative 3 times f of 2 squared times f prime of 2. So now this is as far as we can get with our limit statement. Okay. We can also we also know that we're going to use limit as x approaches 2 of h of x to find f of 2. So we know our function is continuous, so that means h of 2 must be equal to limit as h approaches 2 for h of x. So we know the limit is going to be this expression here. So we take that, put it in here. And now we're going to algebraically try to get f of 2 by itself. So if I cross multiply here, I get 4 over 4 is equal to negative 3 f of 2 squared f prime. 4 over 4 is just equal to 1. And we're going to continue cleaning this up. So divide both sides by negative 3. We get negative 1/3. Now f of 2, we know that since the limit satisfies L'Hopital's rule, we know that 1 minus f of 2 cubed must be equal to 0. So we know f of 2 cubed must be equal to negative 1. So f of 2 must be equal to 1. So we know f of 2 is equal to 1. So we put that in for f of 2. F prime of 2, that's the only thing left for us to solve. So divide both sides by 1. We get f prime of 2 equals negative 1/3. Okay, part D. It is known that g of x is less than or equal to h of x for x values between 1 and 3. Let k sit nicely between g and h for all values between 1 and 3. Is k continuous at x equals 2? Well, at the beginning of the problem, we're told that g and h are twice differentiable, which also means continuous. And g of 2 and h of 2 is equal to 4. So I just sketched a graph here to indicate that relationship there, that h and g are both going to share the same order pair at order pair 2, 4. But h is always going to be greater than or equal to g of x, and k is going to sit nicely between g and h. So if the bottom function and top function are meeting at the same order pair, then k of x, in order to fulfill this relationship, must also share that same order pair, and that's by squeeze theorem. Okay, so since g of 2 and h of 2 are both equal to 4 and k sits between the two values, we know that k of 2 must be equal to 4. Okay. We also know that the limit as x approaches 2 from both sides of g and h are equal to 4, and so our function is going to be continuous. If that's continuous, our function k of x is going to be continuous through that same point, through by squeeze theorem, and it'll be continuous at 2, and it'll have to go through that order pair 2, 4.